Sequential search is a search algorithm which compares each element until it reaches its target. The main difference between sequential and binary search is that the array does not need to be sorted. Here's a visual example on how sequential search works. Let's say we have an array of ints 12, 9, 3, 5, 4, and 8. I want to search for the int 4. First, the algorithm will start at the first index. It will compare the two ints, and since 4 and 12 are not equal, it will return a false. Then it will go down to the next index. Since 4 and 9 are not equal, it will then again return false. It will continue doing this until it reaches its target element or reaches the end of the array. When it reaches its target element, it will return a true, which then it returns the index number. But should the algorithm reach the end of the index without finding its target element, the algorithm will return a -1 as the index number. Here's an example of sequential search in Java. First, the method needs to return an int, and the parameters need to be the array that it's currently looking in and the element that it's looking for. First, simply make a for loop using the array as an index size. So index numbers dot length and index plus plus. Then inside the for loop, create an if statement which compares the current index that it's looking at and the element that it's looking for. So numbers index inside the brackets is equal to key. Next, put return index so that should numbers index is equal to key returns true, then it'll return the index number since that's what it's looking for. Outside of the for loop, return -1 so that should the algorithm fail to find an index that contains the key, it'll return a -1 so it'll be able to run without errors.
So beginning with the concept of binary search, I've provided a visual example of basically what it does, and some pre-existing conditions that binary search has is that one, you must be provided with an int or double, that's standard, but it also must be the data array that you're given must also be from least to greatest order, or you can reverse a couple of things and then make it from greatest to least. So Windows thought my processor speed was slow. In this example, I've given an array. It's not in sequential order, but it is a least to greatest array of 8 values. So 1, 3, 4, 5, 7, 8, and 10 right over here. So binary search, binary meaning 2, it is go away, and you would split it down the middle. So you find that index where it is. You'd split it down the middle, and then you just, in the case of an odd array, you just add 1 to it, or in this kind of array, because there is no middle value. Now, if you had an array of 9 values, then you pick the one that's index is 4. Yes, 4. So you'd split it, and then you have an array. Because the number I wanted to search was 3, which is up here, since 3 is less than the 7 right here where my mouse cursor is, then I'm going to take the second half, or the first half of this array. So I found the middle, and I found the middle of this smaller array. And is it equal to the number I want to search for? No. Okay, well, is it less than it? Yes. Then I'm going to take the first half of this halved array, if you will, from the big array, and I'm going to shorten it again. So dividing it by 2 again. So you just keep dividing by 2. And I find the middle of this 2-digit array, or this 2 index array, which happens to be 1 and 3. Now that we shortened it down, because 3 has been less than on the first side every time. And 3 is a match. So, yeah. 3 is the, so you have 3 test cases for each one, where you find the middle first, and you test to see if the number you want to search for is less than, if it's greater than that middle, or if it's equal to. If it's equal to, you just return that value, and then you have your find. Here we have some example code of binary search that we would use in Java. Over on the right here, or left for you guys, I've initialized an array called R that has 10 values, and it has the values 0, 0, 1, 2, 3, 4, 4, 6, 7, 8, and 1, 2, 3, 4. I've included two fours, just so you can see what would happen in various situations where you had duplicate numbers even right next to each other. And I've also included very large numbers, so you know it's just not one right after the other, because I could have put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all from least to greatest order as I specified in the visual representation of what binary search actually does. So moving over to the binary search class over on the right for you guys, I've initialized a array values that hasn't been assigned any placeholders for indices yet, because we're going to pass that in parameters. And we have the middle value, a middle class variable where that is the middle, the location in the array values that we want to split it at and test and see if it's equal, less than, or greater than that I mentioned in the visual representation. And also we have the minimum, so we don't have to like do what we would do with say a string, where we do a string.substring. This so we can search just a limited size without resizing and losing values on the array. So I just know this is the minimum search I'm going to start at for searching, and then the max search is the maximum value. So as I split, I will change those to indicate the new size or region I want to search. And notice that I've also started at 0, because I know the minimum will always be 0 when I pass the array, as I'm going to test the whole thing, get the middle of that, and then go from there. And then the max search, that is dynamic with the array that I pass. And the search method, which is obviously the most important method in this class, I pass an int, or it can be a double, of v, which is our value that we want to search for. So just some redundancy where we have this min search, which is referencing the class variable, gets 0 in case it gets changed in any which way, which it could if you did multiple instances of binary search. Max search gets values. Length, which is the array that we passed, and that it gets that -1. So say if it's 10 values here, if I get length, it's going to give me 10 and then -1, so 9. So 9 is the maximum indice that I will search at, which is placed into max search. Rather large while loop here, where min search is less than or equal to max search. So while min search has to be less than or equal to it. So if max search eventually gets past it, it will stop running. Which it would happen if no value was found, which is in the case that no value match was found. So say if over my main I passed 5, which we don't have a 5, it would return a -1 here, because max search would eventually get past min, and it would become less than and stop the while loop. So beginning with, we get our middle. So to find our middle value, we get min search, which is at the beginning is 0, and max search, which in our case is 9. Now divide that by 2, you get 4.5, and it truncates it. So you'll start splitting at index 4. Okay, and so you have a difference. You subtract the difference. Okay, so this values.middle returns a value, which in this case would be 4, just like it is in the index. I could put, let me reorder some of these. So I could put 6, 6, and just for the sake of demonstration, I could put 5 there, so it's a different number, so we know the difference. So values.middle will return for just that one section. I almost touched it on my screen there. It would just return a 5. And so I'd subtract the number I'm searching for. In this case, I'm searching for 1, 2, 3, 4. And it would return a value that is greatly negative. But if I wanted to search for 5, the difference would be 0, correct? Because it's just basic subtraction. So in that case, we have found the value that we're looking for in the middle, and we just return it with return this.middle. Now in the case difference is less than 0, which is the case that we actually have, where it's vastly negative. Okay, so because we know it's less than, it's going to split off that array, and it's going to make the middle that new min search. So we've split it off, and the middle has now become that min search that we want to search for, because if the value that we're searching for is greater than, indicated by the difference being negative, we get that second half of the array. And we want the middle that we found to be the min value while the max value stays the same. And in the case that we were searching for a number that was less than, say we were searching for 1, you would have a positive difference, which is the only else case out of this. So this actually isn't programmatically correct. So if diff was greater than 0, then we would have a case that we would want to get the first half of that array, because the value that we're searching for would be less than the middle value that we found. And so in that case, max search, so the maximum value that we would search at in oncoming cases would be the middle. So we have that, we split it down, we have this middle value. If it's less than over here, then we're going to make that max the middle minus 1, so just to get rid of one extra value, because we have tested for that value already with the difference is equal to 0, if that's true. So the max search changes to that middle, and the min search stays the same in the case that the number that we're searching for is less than the middle value that the program found. And so in this while loop, it runs it continuously until it gets down to where it passes, and if no match is found, it returns a -1, like I said before. So we're going to search for 1, 2, 3, 4, and we should get an output of 9, which 9. Successful. We can also try some other values. Say we wanted to try 5, like I said before. Let's try that. 4, which is the index that 5's at. Cool. So that is the demonstration of how you would actually apply a binary search concept to Java, which is very important because it is much faster in most cases of very large arrays to search that versus sequential. But the catch is with binary is that you have to have a ordered array. It has to be least to greatest or greatest to least. In that case, we would just change the greater than or less than, because it would just be in a different order. It has to be in that order, otherwise it screws up, and you'd have 0, 1 to 2, that crazy number, and then the 45. You'd have crazy numbers all over the place. And if the middle was 4, say I was searching for 45. Is 45 greater than 5? Yes, so it would actually split it to where I was searching for these values instead, whereas there actually is a case up here that was at an index less than 4 in which there's a match. So that is binary
So here are some
search.
sequential and binary search multiple choice questions. Number 1. Consider searching for a given value in an array. Which of the following must be true in order to use binary search? 1. The value must be integers. 2. The value in the array must be in a sorted order. 3. The array must not contain any duplicate values. Please pause the video to answer the question. Number 2. Consider searching for a given value in a sorted array. Under which of the following circumstances will sequential search be faster than binary search? Please pause the video to answer the question. Okay, question 3 refers to the following code segment. Assume that variable a is an array of ints of length n. Assume that swap correctly swaps j and k values of array a. Which of the following assertions is true every time line 6 is executed? And it's referring to this line. Please pause the video to answer the question. Number 4. Consider searching for a given value in an unsorted way. Which of the following will be the most efficient? Please pause the video to answer the question now. If a sequential search is looking for the integer 3, which will be the index number it returns when it runs in this array? Please pause the video to answer the question now. Here are the answers to the 5 questions.